There is a special case that you will sometimes see in rational equations, and that's when you have a proportion. A proportion is an equation in which you have a single fraction set equal to another single fraction. For instance, a over b equals c over d. When you have this situation, and it has to be a single fraction equal to another single fraction, then you can, instead of using the LCDs, just get rid of the fractions by setting cross products equal. Now, what is a cross product? A cross product is when you multiply the diagonal values. So a times d would be one cross product, and b times c would be the other cross product. It turns out this will always be equal as long as your denominators are not zero. So this is a special way to get rid of fractions. Notice all fractions gone. And we can solve any rational equation that has this format using cross products. So let's give this a shot. 40 over x equals 8 over 5. Set cross products equal. So we'd have 8x equals 40 times 5. So 8x equals 40 times 5 is 200. Divide by 8. And we get x is equal to 25. We could check that the same way we've checked the other equations. Just go back to the original equation, put the 25 in, and simplify both sides. In this proportion, 8 over 5 was already simplified. On the left-hand side, 40 and 25 both have a 5 in common. You take the 5 out of 40 and you get 8, 5 out of 25 and you get 5. So as you can see, that simplifies very nicely. You get the same thing on both sides. So the solution is 25. And on my next example, I have y plus 10 over 3y minus 8 equal to 9 over 8. I'm going to set cross products equal here. So I'm going to have 8 times y plus 10. You have to multiply the 8 by all of the numerator, y plus 10, so make sure you use parentheses there. And the second cross product, 9 times the original denominator, 3y minus 8. So we're going to get 9 times, in parentheses, 3y minus 8. And again, those cross products should be equal. So simplifying by distributing the 8, 8y plus 80, and the 9, 27y minus 72, we now have an equation without fractions. We can move the variables to one side, so I'm going to subtract 8y from both sides. So I'm going to get 19y minus 72 on the right side. Add the 72 to both sides. So I will get 152 equals 19y, and then divide both sides by 19. Y is equal to 8. So here we have a solution. We can check that. 8 plus 10 in the original equation over 3 times 8 minus 8. That should be equal to 9/8. 9/8 is already simplified, so I'll just work on the left-hand side. 18 over 24 minus 8. 24 minus 8 is 16, so I have 18 over 16. 18 over 16, both have a 2 in them. Divide out the 2 and we get 9/8. Same thing on both sides. That means those check. So we had a solution in the first equation of 25. And in my second equation, the solution was 8. Here are two more examples of solving equations using cross products. Remember, we can only use this technique if we have a proportion, a fraction equal to a fraction. This first equation may not look like it's a fraction equal to a fraction, but the 4, any whole number, can be written as that whole number over 1. So when I write it that way, you can clearly see that it is a fraction equal to a fraction. So we can set the cross products equal. X times 1 is just going to be x. And then 4 times all of that first denominator. Make sure you use parentheses and distribute. So I'm going to have x times 1 is x equals 4 times x plus 3. Distribute that 4. We're going to get 4x plus 12. We have two x terms. Let's move the x's to one side. So I'm going to subtract the 4x to get it away from the 12. So x minus 4x is negative 3x. Equals 12. Divide out the negative 3, and x is equal to negative 4. So that should work if we've done our work correctly, and as long as it doesn't make a a zero denominator. So let's try that out. Negative 4n for x, everywhere we see x. Is that really equal to 4? Well, let's calculate this left-hand side. Negative 4 over negative 4 plus 3 is negative 1. Negative 4 divided by negative 1 is 4. We get 4 on both sides, so that checks. So the solution is indeed negative 4. In the last equation on this page, let's go ahead once again and set cross products equal. There is something that does occur here that we need to be aware of. There's a negative out front on this second fraction on the right side. That negative is going to get in the way unless it's clearly in either the numerator or denominator. I recommend just putting it into the numerator. So really what we're dealing with is negative 7r plus 4 over r minus 4 equals negative 7r over r minus 8. Now you could have moved it to the denominator, but if you moved it to the denominator, you would have to multiply the entire denominator by negative 1. It's easier just to move it to the numerator because there's a single term in the numerator. Now let's set cross products equal. So we're going to have two binomials multiply each other in the first cross product. And in the second one, we're going to have negative 7r times r minus 4. So the result is going to be negative 7r plus 4 times r minus 8 equals negative 7r times r minus 4. So lots of multiplication to do. Just take your time. I'm going to FOIL out the left-hand side. Negative 7r squared. Negative 7r times negative 8 would be positive 56r. And then in the inside term, 4 times r, it would be 4r. And the last terms would be negative 32 when you multiply 4 and negative 8. On the right-hand side, I'm just simply going to distribute the negative 7r. So negative 7r squared, and then positive 28r. Now initially it looks like it's going to be a quadratic equation because we have an r squared term. But if you look closely, if we add 7r squared to both sides, the r squareds are going to cancel each other out. So these are going to actually go away. So even though it looked like a quadratic, it ends up not being one because those terms cancel. So we end up with 56r plus 4r is 60r minus 32 equals 28r. When we subtract the 60r from both sides, we're going to get negative 32 equals negative 32r. That's rather nice. We get r equals 1 when we divide out the negative 32. So it looked pretty complicated, but it turns out to be a pretty nice solution. So if we want to check this, checking both sides, let's see if I can fit it in up at the top here. Negative 7 times 1 plus 4 all over 1 minus 4. Is that equal to 7 times 1 all over 1 minus 8? And remember there was a negative out front as well. So left side would be negative 7 plus 4 is negative 3 over 1 minus 4 is negative 3. That simplifies to 1. On the right side I have the negative out front, and then I have 7 over negative 7. Negative 1, when I divide the 7s, is going to be positive 1. So I get a positive 1 on both sides, so that checks. So my solution here is indeed 1. So when you have proportions, instead of using the LCD, the easiest way to clear fractions is to set cross products equal.